Welcome to the Maths Made Easy tutorial on 3D Pythagoras. So 3D Pythagoras is essentially just 2D Pythagoras twice, and I'm going to demonstrate the proof of it here. So suppose we had a cuboid where the side lengths are A, B and C, so that's the width, the depth and the height respectively, and we wanted to work out the distance from this front corner here in the bottom left to this back corner here in the top right. So let's call that D. So could we express D in terms of A, B and C? And the answer is yes, we can. And the way we go about doing that is we first of all divide the base of the cuboid into two right angled triangles. So you can see there's a right angled triangle here, and there's another one here, but we don't need to consider that one. So first of all, let's consider this right angled triangle here. So we can work out the length of the hypotenuse of this right angled triangle, and we'll call that x. So to work out the length of x, we just use 2D Pythagoras. So x is the hypotenuse, so x squared equals a squared plus b squared. But x is not only the hypotenuse of this triangle that forms the base of the cuboid, but it's also the base of a second right angled triangle here, where D is the hypotenuse. So we can write another expression using 2D Pythagoras. So D squared, the hypotenuse, equals x squared plus c squared. And now you can see that we have two expressions involving x squared. So let's call them 1 and 2. So if we substitute the expression for x squared, so that's this part here in equation 1, into equation 2, so we put the first part into the second part, then we get d squared equals a squared plus b squared plus c squared. So we can use this expression d squared equals a squared plus b squared plus c squared to find the length of any line in 3 dimensions when we know each component. So let's take a look at an example question now. So shape ABCDEFGH is a cuboid. Find the length of side FC to 3 significant figures. So FC is the one that's been highlighted in red. So let's just rewrite our expression for 3D Pythagoras. So that's d squared equals a squared plus b squared plus c squared. So what's A, B, C and D? Well, D is the hypotenuse in 3 dimensions. A, let's say that A is this 9 centimetre side, and then B can be this side EH, which we don't yet know, and then C is this side 5 centimetres. So first things first, we have to work out what B is. Now we have an angle here and an adjacent side, and the side B is opposite. So the expression we need, or the trigonometric function, is the tan function. So tan x equals opposite over adjacent. So in this case x is 26. So tan 26 equals opposite. So that's b divided by the adjacent, which is 9. So therefore b equals 9 tan 26. So if we plug that into the calculator, 9 times tan 26, that gives us a value of 4.3895 blah blah blah. So 4.38 ... We'll leave it in the calculator for now. Okay, and now we can use our 3D Pythagoras expression to find the length of D. So if we substitute in our values then, so d squared equals A is 9, so 9 squared, plus B we've just worked out is 4.38 something or other squared, and then C is the 5 centimetre side, so 5 squared. So if we plug these into the calculator now, so remember we stored our answer from the previous part, so if we square that now, that gives us the value of B squared, and then we add 9 squared and we add 5 squared. So that gives us a value of 125.26 something or other. So d squared equals 125.26 ... And then finally we just have to square root our answer. So d is the square root of the answer we just had. and that gives us 11.1923, or to three significant figures as the question asks, that's 11.2. So D equals 11.2 centimetres, and that is the side length FC. So there's just a couple of things to point out with this question. The first is that I stored all my answers in the calculator, so you can use the answer key to do that if you want. And the reason I do that is because it helps me make sure my answer is accurate to three significant figures. So I've only done my rounding at the end of the question. And the other thing to point out is that I could have done this question differently. I could have worked out the side length FH first of all, and then used 2D Pythagoras to work out the length of D, or the side FC. And to get FH, all you do is use the cosine function, because you have an adjacent side and a hypotenuse, so therefore cos, so the cosine function is cosine equals adjacent over hypotenuse, so cos 26 equals 9 over FH, and then you just solve for FH. Now, 3D Pythagoras can be a challenging topic, but we do have an online exam available, so you can get some practice in before your exam. If you take the test, you'll find loads of different questions to have a go at, and you get instant feedback on all of them, so you can see the solutions as well, find out where you went wrong, and so on. So if you're interested, then click the link below, it will take you straight over to the exam.